Everyone, welcome to Math and Science Clinic. Today we will discuss about atoms and molecule, that is the chapter 3 of Ncert class 9. So let's begin. We already learned about the historical background of atoms and the importance law, that is the law of conservation of mass and the law of constant proportion. This is law combinedly called law of chemical combination. So we already learned about the Dalton atomic theory given by John Dalton, which is based on these two laws. Today we will discuss about atoms and molecules. What is an atom? Have you ever observed a massive building walls? From this wall a room, then a collection of the room to form a buildings. What is the building block of the huge buildings? What is about the building block of ant hills? It is the small grains of the sand. Similarly, the building block of all the matter are atoms. Just like the huge building or the ant hills have small sand, those are the building block of this huge building or this sand hill. All the matter around us are composed of the basic building block called atom. So atom is the basic building block of all the matter around us. How big are atoms? Atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms when stacked would make a layer of barely thick as the sheets of paper. So atomic radius is measured in nanometer. That is 1 by 10 to the power 9 meter is equal to 1 nanometer. That is 1 nanometer is equal to 10 to the power minus 9 meter, which is the unit of atoms, atomic radius. So relative size of different substances given with the atomic radius. So that is the hydrogen 10 to the power minus 10 meter. And molecules of water is 10 to the power minus 9 meter. Molecules of hemoglobin, which is present in our blood, it is 10 to the power minus 8 meter. Grains of sand, ant and watermelons, all those have a different radius. So here it describes that atom is so small that we can't imagine or compare it, because it is very small, that is 10 to the power minus 9 meter is the atomic radius of atoms. We might think that if atoms are so small, insignificant in size, why should we care about them? This is because our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Through the modern technique, we can now produce the signified image of surface of elements showing atoms. So as atom is so insignificant in size, so small in size, why we should not ignore it? Because all the substance around us, all the matter around us is composed of atoms only. Atom is the building block of all the elements. So it is directly or indirectly affect our life. So we should not ignore it, and we should know about the basic structure and basic function of these elements and atom. This image shows the image of the surface of the silicon. If we see the magnified image of the surface of silicon, it would look like this. What are the modern day symbols of atoms of different elements? Dalton was the first scientist who used the symbol for the element in a very specific sense. When he used the symbols for the element, he also meant the definite quantity of that element, that is one atom of the element. Bosler suggested that the symbols of element can be made up of first one or two letter of the name of the elements. So in the beginning, name of the element were derived from the name of the place where they were found for the first time. For example, name of the copper is from the Cyprus. Name were also taken from the specific colors. For example, gold was taken from the English word that is naming yellow. Nowadays, IPAC, that is International Union of Pure and Applied Chemistry, approved the name of the element. Many of the symbols are first one or two letter of the element in the English. The first letter of the symbol always written in the as capital, and that is in the uppercase, and the second letter is the small case, that is the lowercase. For example, hydrogen is H, aluminum is Al, cobalt is Co. Okay. So first the symbols of the different atoms is given by John Dalton. So he represent the atom as element, symbols of element, just like this. The hydrogen, this is the symbols of hydrogen, and carbon, oxygen, iron, just like this. Each symbols represent one atom of the particular atoms. For example, this represent one atom of hydrogen, this represent one atom of lead, this represent one atom of copper, this also represent one atom of platinum. Okay. Later on, Berzelius give the idea of the symbols, just like the first one or two letter of element. That is aluminum stand for Al, the first two letter, and the first letter is always capital and the second letter is small. Just like other symbols are such as hydrogen represented by H, which is the first uppercase letter, that is the capital letter of the name hydrogen. H come from hydrogen, which is symbolized as hydrogen. Hydrogen symbolized as H, capital. In the beginning, name of the element are also derived from the place where they are obtained, such as copper is obtained from the cypress. Copper, that's why it is called copper. So copper is obtained from the cypress. Just like that, we can get different elements from their countries, just such as germanium is from Germany and polonium is from Poland, just like that. So we got the name of the sum of the element from the color, that is the gold. Gold in English meaning yellow. So gold means yellow. That's why it is called as gold. As the gold is yellow in color, so its name as gold, because gold means yellow in color. Nowadays, IPAC is given the international organization, that is International Union of Pure and Applied Chemistry. It approved the name of the elements with their symbols. So many of the symbols as the first letter of the English, it is already discussed. Okay. Here is example of the different element, that is hydrogen. As I already told, hydrogen is represented by capital S, aluminum is capital A and small l, not capital A and L. The first letter is capital and the second letter is small. Cobalt represents Co, such as copper is represented by Cu. Symbols of some element are formed from the first letter of the name and the letter appearing in the letter of the name. For example, chlorine is Cl, zinc is Zn, etc. Other symbols have been taken from the name of the element in the Latin, German, Greek, etc. For example, symbols of the iron is Fe, and it is from the Latin names, that is ferrum. Sodium is Na from the nitrium. Potassium is K, that is kalium. Therefore, each element has a name and a unique chemical symbols. So here given is some element have their name, their symbol, that is not from the first and second letter. It can be from the first and the letter in the latter part. That is the zinc is not represented by Zi. It is represented by Zn. This is the correct way and this is the wrong way. So you have to remember all this. So similarly, chlorine is represented by Cl, not by Ch, which is the first and second letter. The chlorine is represented by Cl. This is the correct way and this is the wrong way. Symbols are always also taken from their Latin name, such as Latin name of a germ. Latin or German or Greek name. For example, the symbols of iron is Fe, that is its Latin name is ferrum. So that's it is called as Fe, not Ir. Sodium is Na, that is nitrium, which is the Latin name, and potassium is calcium, that is represented by K, capital K, that is calcium. Okay. Atomic mass. Most remarkable concept of the Dalton atomic theory was proposed was the atomic mass. According to him, each element had a characteristic mass. The theory could explain the law of constant proportion so well that the scientists were prompted to measure the atomic mass of element. Since determining the mass of individual atom was a relatively difficult task, so relative atomic mass are determined using the law of chemical combination and the compound formed. Let us take example of the compound carbon monoxide formed by the carbon and oxygen. It is observed experimentally that 3 grams of carbon combined with 4 grams of oxygen to form carbon monoxide CO. In other words, carbon is combined with 3 times of the mass of the oxygen. Suppose we define the atomic mass, earlier abbreviation, as AMU, but according to the latest IPAC recommendation, it is now written as U, that is unified mass. Earlier it was abbreviated as atomic mass unit AMU, but now it is unified mass, equal to the mass of the carbon atom, one carbon atom. Then we would assign the carbon atomic mass as 1.0 U, and that of oxygen is atomic mass of 1.33 U. However, it is more convenient to have this number as a whole number or as near to the whole number as possible. While searching for the various atomic mass unit, scientists totally took 1/16 of the mass of the atom naturally occurring oxygen as the unit. This is considered the relevant due to the two reasons. Oxygen reacted with a large number of elements, so form compound, and the atomic mass of the unit given mass of the most of the element in whole number. However, in 1961, universally accepted atomic mass unit, that is carbon-12 isotopes, chosen as a standard reference for the measuring the atomic mass. One atomic mass unit of a mass unit is equal to exactly the 1/12 of the mass of the atom of carbon-12. Relative atomic mass of all the elements have been found with respect to the atom of carbon-12. So, in the Dalton atomic theory, the most remarkable concept was the measuring the mass of atoms, that is atomic mass. So, it is based on the phenomena of, that is the law of constant proportion, and it is not easy to measure the mass of each and every atoms. So they use the relative atomic mass were determined by using the law of chemical combination. So for example, carbon monoxide, we have to take the carbon with oxygen to form carbon monoxide. That is, he took experimentally and to find out that 3 grams of carbon is combined with 4 grams of oxygen we form the carbon monoxide. So that this is how they do experiment. So oxygen is atomic mass. If they take those value, then using this unified mass, earlier it is called as atomic mass unit, but later it is termed as unified mass according to the IPAC recommendation. So we would assign that the atomic mass of the carbon is 1.0 U unified mass, and that of oxygen is 1.33 U unified mass, 1.33 unified mass. However, it is more convenient if it is in a whole number. So they search for something which will takes the atomic mass of element in whole number. So they come with the conclusion that if they took oxygen oxygen as a relative mass of all the element. So it would be easier because oxygen is reacted with most of the large number of the elements, and atomic mass of the mass unit gives us the most of the element in whole number. So atomic mass we can get the numbers in whole number by using oxygen. Later in 1961, it was found that the carbon 12 was taken as the relative mass of the elements. So it is taken as standard reference for measuring the atomic mass. Okay, that is, we have to measure the atomic mass of element. We have to multiply it 1 by 12th of the mass of the carbon atoms. Okay, so here is a story that is, imagine a fruit seller selling fruit without any standard weight with him. He take a watermelon and say, this has the mass equal to 12 unit. He makes 12 equal part of the watermelon and find the mass of each fruits as he is saying, the relative to the mass of the piece of the watermelon. Now he sell the fruit by relative fruit mass. That is the relative fruit mass. That is the fruit mass unit. Just like the atomic mass unit, this is called fruit mass unit. Is an example of that is, if he cut the watermelon into the 12 equal part, then each piece of watermelon is equal to one fruit mass unit. Okay, so see, he now use this as a unit of measurement because he do not have any standard unit of measurement. So he use this as a unit of measurement and weighs the different fruit using this watermelon, a piece of watermelon. That is called one fruit mass unit, FMU. So here is example of different element with the symbols. So you have to remember all this because without the symbols, atomic number, atomic valency and the different ion, we are not able to form the different compound, which is very essential for chemistry. So different element are example: aluminum Al, argon Ar, barium Ba, boron B, bromine Br, calcium Ca, carbon C, and there are different elements. So you have to remember all this with their symbols. So here is example of some of the important element with their atomic mass. So hydrogen is one mass atomic mass unit, that is 1 AMU. Carbon is 12 AMU, nitrogen 14, oxygen 16, just like this. So you have to remember all this. Okay. So how do atom exist? Atom of most of the element are not able to exist independently. So atom form the molecules and ions. These molecules and ions aggregate in large number to form the matter that you are able to see, feel or touch. So most of the atoms are present in their molecular form, not in atomic form, because they cannot be present in atomic form. But some atoms such as helium, neon, argon, krypton, xenon, radon, those are present in the monoatomic form, that is single atom is presented by them. So because they do not react with most of the element, they do not react with any of the elements, so that they are present independently, that is in the atomic form. But most of the other atoms are present in the molecular form. So when those molecules are aggregate and combined in large number, so that is for the matter which we are able to see or feel. Okay, this is all about atoms, and in the next class we will study about molecules. So thanks for watching. Please like, share, subscribe my channel. Keep learning and stay blessed.